Great. Hello, everyone. We're Robert, Richard, Jensen, Tony, and Calvin, and we're the team behind BallerStats. So the main problem we're trying to solve with our project is to better find advanced basketball statistics for everyday users, specifically with just using your smartphone and then running our program. So basically, we wanted to focus on the distance traveled during a pickup basketball game. And currently, this is a problem because advanced statistics only really available to professional players, and it's still really inaccessible for everyday users to try to find these types of statistics. So yeah, there are a few current approaches to this problem, but they both involve either collegiate or professional basketball players. So basically, a group of Stanford University students recently used video footage from an NCAA game to track players and also to find ways to track advanced statistics, such as where they shot the ball from and just the distance that they traveled as well. And then the NBA, or National Basketball Association, currently uses a company called Second Spectrum, which is a machine learning and computer vision company that's focused on tracking players in various sports in order to obtain advanced statistics.
Our approach combines camera calibration, tracking, and depth estimation to find the distance traveled by the player. So we first obtain the intrinsic camera parameters with a checkerboard camera calibration. We then draw the bounding boxes around each player and also a landmark with a well-known distance. And then we use the CSRT tracker from OpenCV to track the players and landmark in each frame. We also use a deep learning model to generate the depth map of disparity. Finally, putting everything together, we convert from pixel coordinates of the image to world coordinates. And then using the world coordinates, we can estimate the distance traveled between each frame.
Because existing videos of basketball were kind of too complicated for a basic model like ours, we wanted to develop a more simple data set for evaluation. So we went over to Leslie Park in Ann Arbor and we did camera calibration, placed our camera on a level surface and fixed it on a tripod. And we took 3 short, 4 medium, and 1 long video of our group mate Richard playing basketball and doing different paths around the court while shooting. Then we then measured the court dimensions to find the distance from the hoop to the camera as a reference for our depth map, and then also computed the total distance traveled ground truth values for each of the videos. So we'd have something to evaluate our model with.
So putting all of the different data points together, when you run our program, we first ask you to draw a bounding box around the player that you want to track. And so we do that, and then we hit enter. And then the next thing that will come up, we'll draw another bounding box around a landmark. This case, it's the top of the hoop for which we computed a ground truth distance for. And then once we do that, we have everything we need to generate the video with all of the BallerStats. We have 2 clips here, and in the second clip, you can see another different scenario, and for each scenario, we overlay over the video the distances that the player has traveled along with the bounding boxes as they move across the scene.
So applying what we coded to our baller set, we got an average error of about 46%. And that error came from consistently overestimating the measured distance. So most of our challenges lie with depth perception, because with more time, it should be reasonable to get a almost perfect camera calibration. The first challenge is that we have extra distance from depth noise. And a way to reduce that noise would be to take the median depth in a bounding box instead of just taking the depth at a center pixel of the bounding box. So that's something we could investigate in the future. The second challenge is biased error. So over or underestimates in depth always lead to overestimates in distance traveled. And what we could do is in the future, we could estimate average distance error and subtract that value from our predicted distance in order to get a depth with error centered at 0.
All right, thank you for listening, and we hope this will improve everyone's stats with our tool.